So hello guys, my name is Wasim Khan. I'm a mechatronics engineer. So welcome to my channel Design and Modeling in Mechanical Engineering. In today's lecture, I will show you how to design and simulate a model in Solidworks 2018. So we have to come across these 4 steps, and in the first step I will show you how to design a press arm assembly, and we will cover some basic design preliminaries that show you how to design and then model and simulate it in SolidWorks. So in the first step, I have taken this example from Mechanical Design Handbook, and the press arm is actually a part from a mechanical press, and I have I want to design the mechanical press. So I will show you how the mechanical press looks like. So this is the mechanical press, in which there is the part which I have been designing. This is the press arm, which has been connected between these 2 power screws. The power screws has been driven by the gears and the gears, and then by motor. So the total force on these 2 power screws are 5,000 pounds. So each one will take 2,500 pounds. So the total force on this part, on this press arm, is 5,000 pounds. So 5,000 pounds force will act. If this is moving in downward direction, then the force will be acted in the upward direction. So this is made up of cast iron, and it is given in 2D. So I have converted it into 3D model by using SolidWorks. Now this is the part which I have shown you in the picture, in this picture. So it is composed of almost 4 parts. The 2 flanges and the one middle yellow plate, which is the main basic plate carrying the load. Now from the very basic, I have put this model into a topology study in SolidWorks, and I want to remove some extra material from this plate, as this is the critical part. So I want to remove some material from this part. So I will show you how to how to perform the typology study and remove some parts and some mass from the design, from the plate, without affecting the original quality or the geometry, or the stiffness of the model. Next, we have to cover some force and pressure load on 2 different models. First, we have to apply a force load on one model and simulate it in SolidWorks, and will show you the results. And then I will perform a pressure analysis. I will apply some pressure load on this plate and show you how the 2 results looks like. This pressure load will be equivalent to the force that I have applied on the model. So in the last section, I will show you how to perform the static and fatigue analysis of both these models. We have to compare these 2 models, and then we'll show you the result, how it affects the final model. So let's start with the simulation process, and I will show you how. So guys, we are now in SolidWorks, and this is the assembly of the press arm the very basic preliminary design that I am initially taking into consideration. Now, before carrying out the static study analysis of this press arm, I will show you some parameters or some understanding of this assembly. Now, as I have shown you that I have taken this example from Engineering Design Handbook, and these two holes are for the power screws that I have shown you earlier, and the whole assembly is made up of three parts. These two are flanges, and this is the middle plate or the bottom plate, which is carrying the load entirely and transfer it into these two flanges. Now, before carrying out the static analysis of this assembly, I have to check the mass of the whole part, and then I will show you how we will reduce the middle plate to transform it into a more flexible and very less weight design. So we will go to the evaluate tab, and here we select the mass properties, and as you can see there, the mass of the whole assembly is 17.31 kg, which is quite a lot because of this plate. And to reduce the mass of this plate, in the next section I will show you how to perform the typology study of this design. Now we go to the static analysis of this part assembly, and I will define every section of this static study, that how I carried out this I have carried out the static analysis of this assembly. Now I have designed all of these three parts as a sheet metal, because weldment is very easily applied to sheet metal parts. So I designed these into sheet metals. Now in the next section, in the connections, I applied welding joints to every section of these flanges and the bottom plate. For your understanding, I will show you one example. For example, I select this face of this flange, and for the set 2 I select the bottom plate, this face. As you can see, the selected face has been highlighted in blue, and it will automatically find the edge that has been welded. This is the weld animation which you have which is shown in this design. And if you want to maximize or minimize the size of the weld, so you can do this with the estimated weld size. And so I select 6 mm weld, and for the whole sections I do the same procedure for these joints. So there is nothing much more in this section. You can select the connections and put weld stepwise for all the parts. Now in the fixture I fix the hole as a fixed support, and I want to show you that how I do this. So I select this face and this face and apply fixed support to these parts. And for the external load, I applied a pressure. As I told you, the total force on this plate is 5,000 pound in the upward direction. As this, I consider this press arm will be moving in the downward direction, so the force or the pressure will be applied in the opposite direction. So the total force is 130. The total pressure is 138.89 psi. How I calculate this? Now I will show you how I calculate this for the from the area of this plate. Now the area of this plate is 36 inches square, and when I divide 5,000 by 36, it comes out to 138.89 approximately. So I applied this much force on this face. Now the whole system is now defined, and these are the boundary conditions that I will be simulating in Solidworks. So after meshing and run the study, it comes out that the total one mesh stresses on this part is about 100 megapascals, while the displacement is 3.6, and the factor of safety is 1.26. So you can see that I have simulated this part as a sheet metal, and it comes out that the factor of safety is a little low in this case. So guys, these are the result of the first simulation that I want to show you, and in the next video I will show you how to perform the topology study of this middle plate, so that we can reduce the extra mass and modify this body to a more reliable and weightless position, and more stable and stiffer than this model. Now for now, thank you for watching my video, and please subscribe and click the bell icon, so every notification of my videos will be on your screen. Thank you guys. Bye.